Welcome to the Thesis Writer's Guide on Making Professional Scientific Figures. This is part one of a two-part series. This part is going to go through some essential information and tips on making figures that should be useful to all thesis writers. In part two, we're going to go into advanced image editing methods for students who are working heavily with scientific images. Okay, so let's begin. Probably the first and most important point of this talk is that figures really contain two different types of objects, vector objects and raster objects. And I'm going to demonstrate the impact those two different objects have on our figures by looking at this PDF that I happen to have on my desktop, Advising Matters. So this PDF, like our figures, contains text, it contains schematics and logos, cartoons that we might draw in to illustrate things, as well as images, in this example, photos. And what we see is the main difference between these vector and raster objects is what happens to them as we look at them at different resolutions. So for example, if we zoom up on this Harvard College logo here, and we're going to zoom in pretty big time, so this is 700%, the object looks just as good. No matter how far we advance the zoom, what we get is even more details and a better view of what we were trying to look at. We can see the fine details of the booklet here, and the font looks just as crisp and as nice as it did at the lower resolution. And this is kind of the cardinal feature of a vector object, is that they get redrawn at different zooms, they're scalable, so you never have to worry about them degrading in quality. We can see the same thing in this text here. As we zoom up, it looks beautiful. Now that is in stark contrast to the raster objects, which are comprised of a set of pixels which limit the information content of the object. So let's take, for example, this image of David Haig. If we were to zoom up on David Haig and try to get some information, how big is his pupil, what color is his eye, you might think that if we could zoom in, we could get to that information, but we're going to run up against a wall here. And that wall is the set of pixels that were acquired when this image was taken. That constrains the amount of information that this image holds. And when we zoom up, we can't get past that. We never see more than what was there when it was acquired. So these images have a set resolution, and if we're not careful about the resolution that we're using, they might look blurry, they might look pixelated whenever we print them out or incorporate them into our figure. So let's take a look at these two different objects in greater detail. We now know that figures are a mix of raster objects and vector objects. The raster objects come to us usually from scans, microscopic pictures, photos, or screen captures, and they are pixel-based. There's a set number of pixels when they're acquired that they retain for forever. When you zoom in, you can see those pixels. So here I'm just zooming in on a small portion of that image, and you can actually see those square blocks. And each of them has a different intensity, and those differences in intensity represent the object that was imaged. These type of objects are ones that we edit in Photoshop or GIMP. We're not really going to talk about editing raster objects in part one of this series, but we will get into it in part two. You'll recognize them by their file type extensions, for example, TIFF, PNG, JPEG, and BMP. These are all raster objects. These are all image files. Now let's compare that to vector objects. Vector objects are usually used to represent shapes, text, graphs, and so on. And you can see they're not pixel-based, they're mathematical expressions, so you can zoom in without blurring. If we were to zoom in on this object, we could just scale it up for whatever zoom we needed it at, however big we wanted to make it. And this obviously has huge advantages for figure making in that the text always looks good, always looks crisp, and that's what we want to do. We want to use vector objects for text, for graphs, for shapes, as much as is possible whenever we're making these figures so that we don't have to worry about resolution issues when it comes time to printing. These type of objects can be created and edited in PowerPoint, which is a very powerful program, or Illustrator. Both these programs have the ability to handle raster objects and vector objects, whereas programs like Photoshop and GIMP can only handle raster objects. So these make nice platforms for us to build figures in. Since Illustrator is a more complex program to use and has a steeper learning curve, we strongly recommend that you make your figures using PowerPoint. And the kind of file types and extensions that you'll see commonly associated with these vector objects are PowerPoint, PPTX, or PDF. Now, before you get started making figures, you want to set up your PowerPoint so that the size of the canvas that you're working with is suited for the final size of the figures themselves. So importantly, before you get started, before you start making designs and integrating your images, first start a new file, go to page setup, make it portrait instead of landscape. Landscape is the default. And make the size, you can set the size whatever you want, make it 6.5 by 9 inches. Right? And what that means is when we insert this PDF into our Word document, Word has a standard letter format of 8.5 by 11 inches, we're going to have a nice 1-inch margin around our figure. And most concentrations require a 1-inch border in the final document. So this will ensure that it's just an easy process ultimately to get this with the right format once you integrate it together with your text. And I'll just show you what that looks like so we can break out of this PowerPoint. We'll make a new presentation. And we go to File, Page Setup. We're going to change it to Portrait Mode, and we're going to change the size to 6.5-inch width. Oops, I forgot a decimal. And a 9-inch height. Doesn't matter, this doesn't have any content, so we can scale up, scale down, nothing's going to be affected. Click OK. And here we go. Now we have a document with the right size. And this is something that we can begin working with to create our figures. You know, for example, we can copy over some images and some text and put that in there. You guys, when you make your figures in PowerPoint, should really consider incorporating the figure legend into the PowerPoint file itself. So you can create, a legend down here as a text box and then incorporate your other images above it. And what we would recommend for your font is using Arial. So Arial is what most journals now request that you use as your font for figures and figure legends. And you can just set that at 12 and keep your figure legend box down at the bottom of your image, right? So now you have a canvas for starting to make a set of figures. And you can keep each figure as its own file, or you can, create all your figures in a single file as you like. Just delete that. Come back to this later. Okay, so now we've got our canvas and we can start thinking about how we're going to incorporate these different objects. And we're going to start by talking about raster objects and how we insert images into our PowerPoint. The key thing to think about when we're dealing with images is the resolution. And again, in part 1 of this talk, we're not going to get into resolution in too great of detail, but there are some things you need to be aware of. And that is that, okay, so this didn't come up in the right order, but I'm going to advance forward so that I can show you. The question is, how do we know if we have sufficient resolution to get clear printed images from the figures that we're creating? And this isn't obvious. It isn't obvious because a printer has a different resolution than your monitor or a projector. So a normal printer prints out at around 220 or 300 pixels per inch or dots per inch, whereas the slideshow, what we're seeing on our screens of our computers or from a projector, if we give a scientific talk, is 72 dots per inch or pixels per inch. Right? And that means that if you have enough resolution to show your image at a certain size at 72 dots per inch, it's going to look really good to you on the screen or on the projector, but it's going to look bad whenever you try to print it out because the printer demands more pixels per inch. And as a demonstration of that, I've got 2 images here, and I'm going to ask you, which one do you think is 72 pixels per inch, and which one do you think is 220 pixels per inch? And it's really impossible to tell because they're both downsampled to 72 pixels per inch by the monitor, so we don't notice a big difference between these two. And since this part of the talk isn't going to get into how to check the actual resolution of your images, I'm just going to show you the quick and dirty way to figure out if this is going to look good when you print it. Obviously, the easiest thing to do is print it and see to make sure that the quality looks good. But if you don't want to do that, you don't have access to a printer, you can also just increase the zoom of your PowerPoint to 300 or 400%. And since 72 is about 3 times less than 220, if we increase threefold, we can see how this is going to turn out when we print it. And now hopefully you can see that there's a lot of detail missing in the left image here. This one is only 72 pixels per inch, so when we try to show it at a much larger size, we see the limitations of the image itself. So anytime you want to check how your image is going to look when you print it out, just go up to 300% and take a look. Okay, now the question is, what can you do about it if you don't like how it looks? Well, to start off, first you need to get your image in there, and there's one important point, which is whenever you're inserting your pictures, please don't copy and paste the image into PowerPoint from some other program or drag the image in. Bad things can happen when you do that. It can change the resolution of your image. So what you want to do instead is to go to Insert, the Insert menu, and then Pictures, and then insert the picture from File. And let's just insert a picture that I have ready to go. And what you can see is it's going to place it there. We don't know what the resolution is, but we get it at a certain display size. Now, if this is too big, that's an easy problem to solve. We can simply use these handles on the image to drag it and make it smaller. Nothing bad is going to happen if we do that. It's just going to compress the pixel size. What we can't do is we can't make it bigger. So let's say we actually wanted a bigger image than this for our figure. We can't expand it using the handles, because what PowerPoint is going to do in order to make it bigger is to add in pixels to the image. And that's creating information. It's not real information. It's kind of extrapolating from nearest neighbors, and it's misrepresenting the information that was actually contained in that image. So the real important point here is you can make it smaller, but please don't resize it to make it bigger. It's going to end up transforming your image into something you don't want. But you're welcome to make it smaller. Hopefully you'll need to make it smaller. And then once you get it to the size you want, you either print it out or go to 300% and make sure that it looks okay. And if you're happy with how it looks here, then that means that it can be used at the size that you have it in your presentation. Okay, so you insert it, you resize it to make it smaller if you need to, and then check the quality at 300%. That's the quick and dirty way. Part 2 is going to get into a lot more details about resizing images. The second thing that anybody with images is going to want to do is edit them a little bit to make them really pop out to the viewer. So two common things that you will do when you're working with images are to crop them and correct the brightness and contrast. And what we can see here is a pretty ugly image of a neuromuscular junction. And it's ugly for two reasons. One is it's got a lot of dead space, empty space that isn't really important, it's kind of distracting. So we can use the crop, just going to Picture, Format, Crop. We get a set of handles, and we can adjust it to get rid of any dead space that isn't necessary. You just want to present the viewer with the information that you want them to focus on, nothing extraneous or distracting. Okay, so now we've brought it into focus by cropping. And you should note that what you masked by cropping is still there, so you can go back and change it, but it's just hidden for now. The second adjustment you might want to make is to adjust the brightness and contrast, and PowerPoint gives us some features to do that. Again, if we select the picture, go to Picture, Format, and Corrections, you'll see it brings up a panel of different adjustments of the brightness and contrast. To the right means that it's increasing the brightness, to the left is it's decreasing the brightness, going up decreases the contrast, going down increases the contrast. So you can see visually, what this is going to look like and pick the one that you like the best. And that can sometimes help make the image appear a little brighter so that it presents a little better in your figures. And bear in mind, when you print these things out, they may look significantly different than they do on your screen. So you might, again, want to give it a test print to make sure that it's adjusted to the right level to look good on paper as well as on your screen. As you can see from that correction, though, there wasn't a very big change in how the image looked. I mean, I'm pretty unhappy with that. I think we could do a lot better. And part 2 of this tutorial is really going to get into how to make those adjustments using Photoshop and GIMP to really make your scientific images pop. But since many of you won't be needing to do this, I'm not going to include that in this part of figure making workshop. Okay, so that's for the raster objects. The other type of objects, the vector objects, get handled in slightly different ways. And there's different kinds of vector objects that are common for thesis writers to use. The first one is shapes and schematics and flowcharts, things of that nature. And PowerPoint gives us a lot of tools to make these different kind of objects. So we can go to the shapes menu here. We see a whole range of different arrows that we can use and a whole range of different default shapes. So you might, be thinking about making some kind of flowchart. That will be easy enough. Or you might try to create your own art. And I know that it seems like there's a limited palette of shapes in the Shapes menu, but in reality, you have a lot of flexibility here. If you right-click on the shape, you can get the Formatting Shape option, and that allows you to get rid of the shadow, which I always hate, and to change the colors and thicknesses of the lines and use gradients. But more importantly, many people might not know this, that you can actually right-click and choose Edit Points. And when you do this, you have the option of adding points into the line path. And when you do that, you're going to have an opportunity to drastically change the object itself. So you can add a bunch of points, and at each of those points now you can delete points, or you can change the shape of the line contours around the points, or you can move the points themselves to make much more abstracted and customized art. So you could imagine making something that looks like a cell, or representing your protein, whatever you wanted to do. The sky is really the limit here. My point is that it's more powerful than most people realize. So if you do have the time and the interest to actually create your own artwork in PowerPoint, you certainly have some tools to be able to do that. And if you create these vector objects in PowerPoint, you don't ever have to worry about the resolution. They're always going to look good. They're always going to be rendered correctly on the screen, on a projector, and on the printer. Okay, so that's one type of vector object. Another type of vector object are graphs. And the beauty of PowerPoint is it's a Microsoft Office product, which means that it plays well with the other Microsoft Office products, including Excel. So if you like to make your graphs in Excel, you're in luck. And I'm just going to pull one up here. It's kind of a standard Excel graph. You can copy and paste that Excel graph right into PowerPoint, into your figure, and you get the same graph editing tools that you do in Excel. So up here in chart design, we have our change of colors, so we can quickly try out a range of different aesthetic options. We can choose different formats and layouts. We can, include legends and really radically change our figure, our graph within our set of figures. So that's one handy thing to do if you're working with Excel. The other handy thing about Excel is if instead of copy-pasting, you right-click and paste special, you have the option of pasting it as a PDF. And PDF, remember, is a vector object, so this is going to be scalable. We don't have to worry about resolution issues. The thing about the PDF, though, is it locks you into the format that you had when you pasted it. So you can't change this now. There's no editing it. You don't have access to the chart designs, but you also can't screw it up. It's kind of locked in. So if you like the way it looks in Excel and you want to keep it that way, you can just paste special as a PDF. If, however, you happen to be using a different kind of program to do your statistical analysis or graphing, there's different ways of getting those graphs into your figures. One possibility is saving them as PDFs or some other vector file format like SVG or EPS, which are common vector file formats, and then either inserting them as objects. So if you go to Insert, Object, and you just choose from File the file that you want, so Graph PDF, and insert it, that might work. I found I get an error when I try to do this regardless of what the file format is. I think this happens on all the new versions of PowerPoint, Mac, and PC. So that doesn't work for me, but another option would be to drag the PDF or SVG file into the PowerPoint itself, and this seems to work, at least for certain file formats. On Mac, it works for all the ones I tried. On a PC, it only works for SVG and EPS. And once you have this thing in here, you can crop it if it comes in with a little extra space. It's a little slower than cropping a raster image, but it gets the job done. And what you'll see is that it preserves it as a vector object. So if we were to zoom up, big time on this, it's a little slow, but it's going to do it. Okay, let's save it first. Once we zoom up, it'll take a second to re-render it with my graphics card. This is a complicated figure, but once it does, you see that it looks beautiful even at 300% zoom. So that is a second alternative way of getting your vector objects in. It's a little finicky depending on your version of PowerPoint. The final way you can do it is by rasterizing your vector object. And normally that's something we'd want to avoid, but if you have no other option, it's doable as long as when you make it a raster object, you do it such that it has sufficient pixel size for the size that you want to include it in your figures at. So what you can do is save it as a TIFF or a PNG from your original graphing program. The trick there is oftentimes it's hard to set the resolution, so it may not have the resolution that you want. You can always put it in your figure and check by zooming up to 300%. If it's not good enough, then you try some of these other options. Another option is to save it as a PDF and then open it in one of these image editing programs like GIMP or Photoshop. And when you do that, it's going to try to turn it into a raster image for you because that's the only type of objects it can work with. And when it does that, it's going to ask you what resolution you want to set it at. So there you get to decide, and you can set it at 220 or 300 or something that you know is safe for the size that you have. So that gives you some more control if you don't have that control in your graphing output program. And the third and final option is to actually take a screenshot of your PDF if you open it in Adobe Reader or Preview. Take a screenshot of that, but before you do, zoom up to 300%. So the image is 3 times larger than you need it, because when you take a screenshot, it's going to take it at 72 dots per inch. But if your image is really 3 times bigger than you need it, then you can just compress it down later to get it to have more pixels per inch. So that's another option. And that actually is a really important option for when you're trying to adapt figures, meaning take figures that other people have created from PowerPoints and include them in your own thesis. And that's a perfectly acceptable thing to do as long as you give credit to the authors that originally made the figure in the figure legend. If you try to just take a screen capture at 100% at the native resolution, you're going to end up with something that looks crappy, it looks pixelated, it's very difficult to read, right? And this happens a lot. This is probably the most common mistake that students make when they're putting together their thesis. You don't want to do that, and all you have to do to prevent it is zoom up to 300% before you do that screen capture so that when you paste the screen capture into PowerPoint, you can reduce the size threefold, compress all those pixels so that the image size will be something closer to 200 pixels per inch. And I just show you here, this is that image from Bozeman where we have our figure that we want to copy. I've zoomed up to 300%. I'm going to take a snapshot. Okay, gotta be patient and drag down. Okay, but once I cover the area, I let it do a screen capture at 72 pixels per inch, and I'll paste it right into my PowerPoint, and then I can shrink it down. And after I shrink it down, all those pixels get compressed so that when I print it out, or if I needed to zoom in, even at 300%, it's going to be looking pretty good, right? You may run into cases where actually the figures in the PowerPoint or in the PDF don't look good at 300%. Then you're kind of stuck. That means that when this PDF was made, they used a low resolution image or rendered it, rasterized it wrong, and you can't make it better. There's no way to clean it up. You either have to choose a different figure from a different PDF, or if the PDF comes from your lab, you might ask them if they have the original high-resolution figure that it came from. Okay, so that's basically everything I want to talk about for adapting, for using vector and raster objects in your thesis figures, but I just wanted to say a final word about file size. So if you're doing, let's say, 10 different figure panels, so you have 10 slides in your PowerPoint, even then, you shouldn't be bigger than 20 megabytes, your total file size of the PPTX file. If you are greater than 20 megabytes, your images probably have an excess of pixels. Usually that's what increases the file size. And since we didn't talk about how you know how many pixels your images have, you just have to guess that that's the problem. And one thing that you can do to correct it is PowerPoint has an option if you go to File, Compress, where it will compress all your pictures to a certain size. Now, you have some options here, at least in the newest version, to do something high def like 330. That's great. That's safe on any printer. You can also do 220, which is pretty standard for printout. Either of those options will be good and ensure that any extra pixels, if these ended up being a lot bigger than they needed to be, will be thrown away, and that will drastically reduce the file size. Be careful though, because when you do the compression, that is permanent. So all those pixels are gone, and should you ever want to change the size of the figure, of the image within your figure, you can't do that anymore without creating problems for yourself. You can't make it bigger. If you wanted to make it bigger, you'd have to reinsert the original to restore the quality. So only do this, once you're pretty sure that the images at least are the right size or aren't going to be any bigger than you currently have them. Okay, and lastly, now that you have this wonderful set of figures, you need to think about how you're going to incorporate that into your thesis. So when you're finished, what I recommend is saving the PPTX file as a PDF. And the PDF, remember, allows you to preserve vector and raster objects. And then you can insert a page from that PDF into your Word document, or you can interleave it into the Word document that's already been turned into a PDF file. The advantages of putting it into the Word document are it doesn't screw up your pagination. The advantages of putting it in the PDF file are it doesn't get rendered twice into a PDF, but that is not going to create any big difficulties. So if you put a PDF in your Word document and then you turn the Word document into a PDF, it goes through that process twice. But it should have a very negligible effect on the quality of your images, so I wouldn't hesitate to do that if that's convenient for you. And if we just take a look at that maybe sounds scarier than it actually is. We created this figure that had the right size. Remember, it was 9 by 6.5 inches. So now what we're going to do is we're going to save as, and we're going to export it as a PDF. So we'll just call it Presentation 5. I'm going to save it on my desktop. I think I didn't save it on my desktop. Let me try that again. Okay, there it is. So now we've got our figures as a PDF, and we want to incorporate that into our Word document. So let's say this is our thesis. This is our actual writing with all the text. And what we need to do is, oops, I already practiced putting it in. Let me get rid of it. Right. So what we need to do is incorporate this into the text, and the most common option that students choose, the easiest and most convenient for the reader, is to insert the figure on the subsequent page to where it was first referenced. So we see here, if I'm referencing figure 1 in the text, I want to insert a new blank page here and use that whole page for my figure. So if I go to Insert, Pages, Blank Page, it's going to give me a blank page. And then, again, I can insert this PDF as a picture, or I can just drag it across. I'm going to insert it as a picture just to be safe because I'm always suspicious of what happens when you drag it. So let's insert picture from file. It's a little slow, I apologize, but hopefully it's going to work here without crashing. Yes, okay, so then we select our PDF. Even though it's technically not a picture, it's going to insert it in anyway. And there we go. We have it. It's inserted. It looks good. But just to be sure, let's right-click on this, and let's go to Size and Position. And we just want to check and make sure that it's not doing anything weird to alter the size. And what we see is that we have 100% relative to the original picture size, meaning that it inserted it at its full resolution, the 9 by 6.5 inch size, so that's perfect. Text wrapping we don't have to worry about because there's no text on this page. That's the advantage of giving it its separate page. And position, we don't have to worry about it. It's centered with a 1-inch margin on both sides. So that's it. Then we would be done. We could do that for every figure that we have. and then we would just save this whole document either as a doc file or as a PDF, and we're good to go. Right, so that is the end of part one. If you are someone who's working with a lot of images and you want to know how to edit those images, especially the brightness and contrast, also the size, please do watch the second part of this series where we're going to get into advanced image editing. Otherwise, if you have any questions about making figures, you're always welcome to contact me. My name is Ryan Draft, and I am the academic advisor in the neurobiology department. Okay, good luck and have fun.